Hi, we're going to do 8M1 Lesson 8, Estimating Quantities. We're going to use our knowledge of powers of 10 and what we learned in Lesson 7 and build on that and understand why we care, what use are these powers of 10, and we're building slowly towards scientific notation, which we'll get to in the next lesson. Exciting. Let's cut over now to our sketch pad and just a second. We are having a little bit of technical difficulty, but we're almost there. Let's see. Are we here now? Let's see what we're doing. Just hang with me here. Hang with me. What are we doing? Now, let's come back for a second here. We're going to go here, and sorry about this. We're going to go do a screen share with what we're used to sharing it with. Okay, now, sorry about that. Okay, so we're going to start off with a few questions, and here's our, basically a warm-up, kind of a warm-up. We're going to go back to Lesson 8, and we're going to use a real-world problem that uses Lesson 7. So I did this search in Google search, and I found that there's 318.9 million people in the United States. And so what I want to do is first of all, I want to bracket this number in powers of 10. So I want to find 10 to the what power is greater than 318.9 million, which is greater than 10 to the what power. And these two numbers here have got to be just one apart. The second thing I want to do then is I'm going to get closer, and I'm going to estimate 318.9 million using a decimal, using a digit times a power of 10. So the first thing we're going to do, so you should pause. So the first thing you should do is pause and do part A. Because this was you should know how to do this from the last lesson. All right, so I'm going to assume you're back now. I'm going to assume you have the answer and you know what digit goes here and here. And the answer, if we solve it this way. This is the way we solved it yesterday. And we said, well, this number has got to have a 1, and then all the same number of digits is the number inside underneath, or just less than. So this is 10 to the 9th power, and this is the number that it's just greater than. And so this must be 10 to the 8th is the number that's just less than. So we can write 10 to the 9th is greater than 318,900,000, which is greater than 10 to the 8th. And that's our answer for A. If you have any problems, this was learned in Lesson 7, right? This is just a warm-up. Now, the interesting thing is what we're going to do in Lesson 8 and what the book wants you to do and what Eureka Math wants you to do is they want you to round. When we're doing this B, where we're going to estimate numbers using a single digit in a power of 10, what they want you to do is first, they want you to round. that's kind of part one. And then part two is then they're going to want you to estimate. And so to round this number, we want to round it to a single digit, round to a single digit. And so this is going to be, if we round that to a single digit, we're going to get, and let's just switch colors here to indicate we're on a different problem here. This is B. We're just going to round it to a single digit, and that's 300 million. It's not 400 million. We don't round up because this number here is less than 5. So we round down to 300 million, right? It's going to, we basically take, it's going to have the same number of digits, and then we got to determine whether we round this guy up or down. And again, we round it down because this number behind it is a 1. So now we have this number 300 million. Now what we want to do our estimation is we want to compare this number to the number that's just below it. So we're going to compare 300 million and the power of 10 just below it. And then we're going to find the number that we need to multiply this by. So the question is what do we need to multiply? What do we need to multiply? Sometimes my pen doesn't write. What do we need to multiply by to get from 100 million to 300 million? And well, it's going to always be an integer when we solve these problems, and this has been this number here has been rounded to 1 digit, and the answer is 3, because if I put a 3 here and multiply that by 100 million, I'll get my 0, 0, 0, 0, 0, 0, and 0, 0, 3. So 3 times 100 million is 300 million. So our answer here is 3, and this is not, this is it. There's our answer. 3 times 100 million is equal to 300 million. So the answer that they're looking for is they want it written as expressed as a power of 10. So I write 3 times 10 to the 8th. So 318,900,000 is about 3.10 to the 8th. Okay, so let's try another one of those, and we'll let you try. And we'll say 408,000, and use that and represent, round, and represent using a single digit and power of 10. So I'll let you pause and try. Pause and try. Okay, now we're back. Now remember what we did before. The first thing we found the power of 10 just, well, first of all, we round to 1 digit. then we find the power of 10 just below our rounded number. And then we find the multiplier. So step one, we're going to round this. Now, do we round to 4,000 or 5,000? We're going to end up rounding up. We got to remember here we're going to round up. So if you didn't round up, go back and fix your answer. And so we get 5,000. The power of 10 just below our rounded number is going to be 1,000 or 10 cubed. And then 3, we got to figure out what times 1,000 is 5,000, and that's 5. 5, so our answer is 5 times 10 cubed. Good. All right. The next thing we want to do is we're going to start to use this, and we're going to build up, and we're going to get more powerful here. We're going to use our powers of estimation to estimate the amount of bacteria we have in this example. So here we got to have all these dishes. We're going to have a number of Petri, they call them Petri dishes. I don't know how to spell Petri. I think it's Petri dishes. And this is in a science lab. And you're going to have these Petri dishes. And inside your Petri dishes you're going to have all this bacteria. And we got all this bacteria. And what we know is we're going to say in each Petri dish, there's lots of bacteria. In each Petri dish, each dish has about 2 billion bacteria. Lots of bacteria inside each Petri dish. Each dish has 2 billion. Now, what I want to do is I want to say I have 300 dishes. And I want to say, or better yet, let's do it like, let's do this. So we want to use our powers of 10 to find number of bacteria. So what kind of problem is this? If I have 2 billion bacteria in each one, and then I have 300 dishes, is this what kind of problem? Is that an addition problem, a multiplication, a division? And for those of you who said this is a multiplication problem, you are right. Okay, so we got to take 2 billion and we got to multiply it by 300, but we're going to use our new learned mechanism of estimation and rounding and finding, rewriting these numbers as powers of 10. And we're going to say, well, 2 billion we're going to find the number below it, which is 1 billion. The power of 10 just below it. And we're going to say that equals 2 times a billion. So 2 billion is 2 times 1 billion. And then 300 is 300. We're going to find the number below it, which is 100. And it's 3 times 100. So 300 is 3 times 100. 2 billion is 2 times a billion, which is equal to 2 times 10 to the 9th. And 300 is 3 times 10 squared. Okay? So now I have to take these two numbers that are written in this kind of funky form, and I have to multiply them together. And we're going to see how we do that now. Let me switch colors, and we're going to say, well, what is 2 times 10 to the 9th times 3 times 10 squared? And now we're going to use our knowledge of that multiplication is commutative. And we're going to go back to our multiplication of powers. We're going to use both of these rules. Now, if multiplication is commutative, then I can just switch these guys. Look what I'm going to do. I'm going to put my numbers next to each other that have no powers on them. And then I'm going to put my numbers that have powers on them next to each other. And how cool is that? That's pretty darn cool. Why? Because I know what 2 times 3 is. That's 6. And I know what 10 to the 9th times 10 squared is, 10 to the 2nd. I just add my exponents. And if I want to write this as a number, I can just write 6 with 11 zeros after it. 4, 5, 6, 7, 8, 9, 10, 11. But I'm just going to leave it written like this because this is how they're going to want it written in your homework. Okay, so we're kind of building into this. Is actually, we're actually starting to do scientific notation. But we're not using that word. We're not going to use that word just yet. Okay. We're not going to use that word till we'll define it more formally tomorrow. But for now, just know that you're doing something pretty powerful. Almost all science is done using numbers and scientific notation because you deal in science with things that are really big and really small. That's my hint to you about why we use it. Now I want to actually do for you exercise 4. This is exercise number 4 in lesson 8. And this one basically says there's 7 times 10 to the 9th people in the world. And it says about 687 million are left-handed. I'm not left-handed, but maybe you are. And so the question is what percent, what fraction are left-handed? What percent or what fraction, or percent are left-handed? Well, we're going to estimate. And so we're going to go back and we're going to estimate. And so we're going to turn this into a number that has only one digit. And I want to see if you can tell me what number would go here. What number goes in front if we're building our estimation? And if you told me 700 million is the right, then I would say you are right. It's not 600 million because this guy is greater than 5 or greater, and so we have to round up. So if 700 million are left-handed, let's write that now as a digit times the power of 10. So we get, well, 100 million is just less. So our answer is 7 times 10 to the 100 million, which is equal to 7 times 10 to the 8th. And this is our left-handed. So we want to figure out what percent is left-handed divided by the total. Left-handed divided by total. And that will give us our percentage. This is our fraction that are left-handed. Okay. So let's see here. 7 times 10 to the 8th are left-handed. And 7 times 10 to the 9th is our total. Oh, this is going to work out nice. So we're going to cancel out our 7s and leave a 1 here and a 1 here. So we have 10 to the 8th divided by 10 to the 9th. Well, that's pretty cool. Our quotient rule says we can subtract. Quotient rule says we subtract our exponents. So our answer is 10 to the negative 1. Well, 10 to the negative 1 is the same as 1 over 10. So our answer here is pretty cool. It's about 1/10 or 10% of all humans are left-handed. And that deserves a happy cat. We'll put a happy cat on each little corner here. Okay, good. All right, now I'm going to do one more. Let's do one more problem. We're going to call this our standard. This is why you came. Maybe this is why you came. But this is our homework help. And I'm going to do a little bit different of a problem, not the same one that we did that you're going to get on that you're going to have to do, but one like it. And so this is going to be how many Lake Michigans fit in one Pacific Ocean. And the clue is Lake Michigan has 6 times 10 to the 15th gallons. And the Pacific Ocean has 2 times 10 to the 17th gallons. So, like Pacific Ocean, I hope you know, is bigger than Lake Michigan, which is represented by the fact that we have to multiply by 10 to the 17th instead of 10 to the 15th gallons. So let's see. If I want to see how many Lake Michigans will fit into one Pacific Ocean, I'll take my one big Pacific Ocean and divide it into my Lake Michigans. My Lake Michigans and divide it into my Pacific Oceans. And so this is our big number, and this is our smaller number. And let's see what happens. Well, I can write this also as 2 over 6 times 10 over 17 times 10 to the 15. I can just separate that out, right? All right, I can just separate this out from this Because if I multiply back, I have to multiply my numerators, and I get 2 times 10 to the 17th, and I multiply my denominators, 6 times 10 to the 15th, and I can get back here. Okay. So now that we have this separated, I can rewrite this one more time. I can say, well, that's a 2 over 6 is the same thing as 1 over 3. And I can do my quotient rule here. Ten to the 17th divided by 10 to the 15th is 10 squared. And now I can start to answer how many Lake Michigans will fit in one Pacific Ocean, because I can also just rewrite this. What's 10 squared? That's about 100. So 1/3 of 100 is about 33. And again, we're just estimating. So about 33 Lake Michigans will fill one Pacific Ocean. And so this should help you on today's homework. Okay, so I'm back. I'd like you to, you can follow me. If you hit the follow button or subscribe button on, it's called subscribing on YouTube, Mr. Lipscomb. So if you subscribe to me on YouTube, that helps me know how many people are actually enjoying these videos. And it will also just let you easily find my next lecture or my next lesson as I continue to add more and more. So if you liked it, you can also just pop. That's good. But also just subscribe, because that helps me to know how successful I've been and whether I'm actually doing all the right stuff that helps you learn. All right. Until next time, when we will be learning scientific notation, I'm signing off for now.